Hello everyone, welcome back to another episode. Today we're going to be doing a physics problem using kinematics in both the x and in the y direction. And for this scenario we have this person who is shooting a quarter into a dish. He's hoping to win this stuffed animal teddy bear. I know, beautiful teddy bear, thank you. And he or she is throwing this quarter at a magnitude velocity of 6.4 meters per second, and that is directed 60 degrees with respect to the horizontal in the counterclockwise direction, as shown here. Okay, and so we are set out to find the height of the shelf above the point which he or she releases the quarter. Okay, so let's do that. To start off, I find it important we're going to draw this velocity vector and put it into its components. So we've got, here's our velocity vector of 6.4 meters per second, and we know that the x component is going to look like this in that direction. We're going to call that the velocity in the x direction naught, and then we're going to say Vy naught points in that direction, and they gave us that this angle is 60 degrees, and so we're going to use some trigonometry to solve for Vy naught and Vx naught. So we know that the sine of 60 degrees is equal to Vy naught over 6.4, right? Because we've got sine is equal to the opposite over hypotenuse. So then we're going to solve for Vy naught, and we get Vy naught is equal to 6.4 sine of 60 degrees. Okay, and I'm going to skip a couple steps, and we're going to go ahead and solve for Vx naught using the same process, but this time with cosine. So we've got Vx naught is equal to 6.4 cosine of 60. There we go. Okay, so that's helpful. Now we're going to move on to the kinematic side of things, and we're actually going to start off in the x direction. So let's write out what we know. So let's look back at our picture. We know that the initial position is 0, and we can call the final position 2.1. Okay, so let's write that down. We've got x initial is equal to 0 meters. X final is equal to 2.1 meters. We know the initial velocity in the x direction is 6.4 cosine 60 meters per second. And then we know that the final velocity in the x direction is going to equal the initial velocity in the x direction because our acceleration in the x direction is 0 meters per second squared. How long it takes to get there, we don't know. Okay, so let's start off with the long equation and see what we can get from that. So we've got x minus x naught is equal to Vx naught times time plus 1/2 axt squared. Then plugging in what we know that the final x is 2.1 meters. We know that the initial is 0. We know that the initial velocity in the x direction is 6.4 cosine 60 degrees. And we know that the acceleration in the x direction is 0, so we're going to zero out that whole term. Okay, so we're left with 2.1 is equal to 6.4 cosine 60 degrees times t. In solving for t, by dividing over the 6.4 cosine 60 term, we get 0.656 seconds. Okay, that will be helpful. That's not an answer, but I'm boxing because it's going to be helpful. Now, turns out this is actually all we need in the x direction. Now we are able to move fully into the y direction to determine this height. Right? We use the y equation kinematics to get us this y distance, this distance in the y direction, the height of the shelf above the quarter. Okay, so let's move on to the y direction. And also another thing is, this was our only unknown, and we have just solved for that unknown. So why bother and do the short equation when we're just going to get Vx minus Vx naught is equal to 0. That doesn't tell us anything. At least not anything that we don't already know. All right, so we're going to move on to the y direction. So we've got y naught is equal to 0, and we can call that 0 because we're going to say we want to know the distance above the quarter. So by calling this 0, whatever the value we get for y final is going to be the distance from here to there. All right, so Vy naught is equal to 6.4 sine 60 degrees, right? We did that earlier. The initial y, we don't know. Time it takes to get there, we said it was 0.656 seconds. And the acceleration due to gravity is always negative 9.81 meters per second squared, unless you're on a different planet. Then it's something else. All right, let's move on. So we're going to start off with the long equation like we usually do. Y minus y naught is equal to vy naught t, 1/2 ayt squared. And plugging in for y naught of 0, vy naught 6.4 sine 60 degrees. And for acceleration in the y, negative 9.81. All right, so we've got y is equal to 6.4 sine 60 degrees minus 4.905 t squared. There's a t term in here. Sorry, let me just move this guy over here. I'm going to say times, times, time. Okay, and here we know that time is 0.656. So everywhere that we see a t, we're going to plug in 0.656. Okay, so plugging that in, that's going to get us a value of y is equal to 1.53 meters. Boom. That is the height of the shelf above the quarter, above the point to which he or she has thrown the quarter. Now, technically, this is all that they asked us for, so we could box this answer and be done, but just for fun, I think that we should find the magnitude of the impact velocity. It's actually easier than you think. So, in review, this is the answer they wanted. Boom, the table is 1.53 meters above the quarter. All right, so now let's find the impact velocity. So the impact velocity is going to look something like this. Here's our dish that the quarter lands in, and it's landing in there at a magnitude that we will call V final, and it's got components that are Vy and Vx, and pretend that this makes a right angle, and we know that the Vf, the impact velocity, or at least the magnitude, right, because this is the hypotenuse, the magnitude is Vf, is equal to the square root of Vx squared plus Vy squared. All right, so we know that because acceleration in the x direction is 0, we know that Vx final is equal to Vx initial, which is 6.4 cosine 60 degrees, okay? So we can make that substitution here, 6.4 cosine of 60 degrees. And then let's go ahead and solve for Vy, right? Because we only did the long equation in the y direction. So let's do the short equation now to find the impact velocity. So we've got Vy minus Vy naught is equal to ay times time, which is equal to negative 9.81 t. We know that t is equal to that 0.656 seconds, and we know that the initial velocity in the y direction was 6.4 sine 60, right? Going back up here, here's our vectors. Here's our vectors for the initial velocities. So we're making that substitution here, down here. Okay, and then we're plugging in the time that we solve for right here. So with that, we get Vy is equal to 6.4 sine 60 degrees minus 9.81 times 0.656, which gives us a Vy of negative 0.893 meters per second. Okay, so boom, there's that. And now let's plug that in to this, right? We're going to plug in negative 0.893, and that gives us, plugging that in, and don't forget to square the terms, but plugging that in, we're going to get an impact velocity, with a magnitude of 3.20 meters per second. Whoa, that was fun. See, it wasn't that bad. And if you wanted to, what you could do is you could do the tan inverse. So like here's theta. And if you were to do the tan inverse of Vy over Vx, you would be able to solve for the direction of the impact velocity. And this would be in the clockwise direction with respect to the horizontal. I'll let you do that. I'll let you figure it out. But that's it for today's video. This was a fun one. And if you enjoyed it, if it was helpful to you, give it a thumbs up. Subscribe to the channel. Thanks for watching.